This recording is for Xiang. Xiang's not here. We just want to give a shout out to Xiang. So, um, um, yeah, Xiang, thanks for not showing up for a very important lesson. I'm disappointed in you. Um, first of all, let's draw pictures. I'm gonna draw a very nice, beautiful pictures of ice cream cone. I just had a Jemiah yesterday for the first time in my life.
For the first time?
Yeah. It's actually pretty good.
What'd you get?
I'd get a Bahama one and the pina coladas one. Oh, what's a good flavor?
I like cherry. Anything?
Ew.
What? Okay, you just think of pina colada, so
Yeah, but cherry is like a reminder of Tylenol.
the cherry's good. You just have to get the right one.
Really?
Yeah, there's two types of cherry.
Okay. So which one's which?
Oh, I forgot which one's the good
Damn, I'm gonna go with 50-50. I think Jackie told me it's cherry. I'm like, which kind of cherry? I don't know. Which one's the better one? So there is a comb, and you should know that this has a radius of 4. So this radius of 4. Now this comb is not going to change, right? The radius and height will change, but the comb is not going to change. The comb is always a stay the same shapes. And this is 16. From here to here, right? Now for the blue part, which is the water, and from here to here is 12. Okay. But I hear this is a 4. So this is a 4 from here to here, and this is 16. Total 16. So those are very, very important informations. Now, what can you tell me about 2 meter cube per second? What can you tell me about this? What is in term of calculus? That was DVDOTD. Good job, Sia. How do you know it's DVDT?
because it's cubic meters.
Cubic meter. Good. Okay. Now, is anything wrong with this expression? I purposely left something out. So what do you think is something wrong here? Read the questions and tell me what's wrong with the 2 meter cube per second.
Oh, minus.
Why is minus? It drains. So please read the questions. This is the keywords, right? Drains. So don't forget that drains is.
What I ended up doing is I kind of left the symbols until the final step. So made sense in the final step, and I make it plus or then use minus.
Yeah, I mean you can do that too, but sometimes you forget. So just kind of be risk, kind of when you read a problem, at least like circle the drain, so that you know when you do that step, it's the negative sign.
I
And
just
that's
want to know, like, would you mark it wrong if it said 2 meters instead of -2 meters?
yeah, you're gonna get a totally wrong answer. Yeah, the sign doesn't matter. Draining and pumping in is definitely a different type of thing. So that's the things that I would tell students. I always pay attention to that. So what are they looking for though? What are they looking for? In terms of calculus, I don't care about the actual question. In terms of calculus, what would it be? All right, DHDT is what you're looking for when the H is equal to 12. Does that make sense? What would be the relationship that we're gonna use here? Relationship. What would be a relationship here we're gonna use? Which is what?
That's 1/3 pi r squared h.
Perfect. So 1 third pi r squared h. Now, hopefully you can foresee the problem. If I were to take a dv dt, d to the dt here, now what kind of problem would I met here? If I got 1/3 pi r squared h, what kind of problem would you foresee? Well, you do need to know that, but the problem is that's not the entirety of the problem. The entirety problem is what? If I take derivative with respect to time, then what kind of rule I have to deal with? Right. Y product. Yeah, inside R and H, right? So the problem is that's a product rule, and we don't have drdt. We have dvdt. We don't have drdt. We are looking for dhdt. Then there was too many variables that we think. So then that means you needed some type of relationship, which is the second relationship, right? Second relationship, right? You need to have a second relationship to find out how do I reduce the variables, right? How do I reduce a variable? So there's got to be a second relationship here. So I hear, what kind of relationship you see besides the comb? You can express in words. Circle, possibly, but it's not a good one to help you here. What kind of triangle? Right triangle, but more elaborate. Turn your head sideways, you should see it. It's one of the relationship I'll tell you when I talk about all the relationship that day. No, 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 no. Keep on looking, keep on going down. No,
No, we can't improve on that. It's always 60-30 idea. Because
similar triangle. There is this triangle here, and there's a second triangle here. Do you see that? And they all share the same 90 degrees because the water is gonna have 90 degrees. So with that, you're gonna have a two type of relationship here. You will have R over H. Why is R over H? R over H is equal to the radius of the comb, which is 4, and this is 16. Why is that? If R is equal to 2, you're going to solve for height. You're going to get height is equal to 8. If R equal to 1, then you're going to have height of probably 4, right? So I can reduce this. So that's going to be R over H is equal to 1 over 4. Does that make sense? Can I do cross multiply? Yep. 4R equal to H. But the problem is I don't want to solve for H. There's a reason why I don't want to solve for H. Think about it. If I plug in this H in there, I will have 4R. So then if I have R, all the things in R, then I have to have a drdt, which is we don't have drdt. So that's a problem. So that we're going to solve for the what? r, which is h over 4. So with that being said, then I will have a volume equal to 1/3 pi r squared, as I'm going to plug in, which is h over 4. Does that make sense? And then square, right? Times h. Does that make sense? Can I do a simplification? So yeah, this one is because h squared over 16 times h. So this one's h squared times h is going to be h to the third. And this will be pi over 48. And that's a volume. Now, what's nice thing about here is I have v and I have h. dv dt we know, and pi over 48 we know that's a constant. We can just leave aside when we take a derivative. So now we're going to take a derivative with respect to time, which is dv dt is equal to 3 pi over 48, sorry, h squared, and then dh dt. Does that make sense? Am I going too fast? It's funny, I will ask, am I going too fast? And I'll go faster. Three over 48 is what? Good. Pi over 16 times h squared and then dh dt and dv dt. Now we know what the dv dt is, which is what? -2, right? Pi over 16 times 12 squared, because we want a dh dt here, right? So when h is equal to 12, then that am I going to get -2 equal to pi over 16 times 144 dh dt. Now what's nice is the 144 and 16 can reduce. They can divide it into each other. What am I going to get? 16 times what equal to 144? Yeah, 9. Because 16 times 10 is 160. And subtract 16 is 144. So that would be -2 over 9 pi is equal to dh dt. Voila, you got it. So what is the history? Is you not only have to have one relationship with a cone, you have to have a side. Is that what you guys called it? No. You have to have a side. Right, a second relationship. So with this second relationship can help you reduce the variables. And this is how you set it up. Where the radius over height of the cone is equal to 4 over 16. And then you solve for that one. And then you can substitute and then plug in and you're going to evaluate. You got it? And there you go. That was a cone problem. You're going to have one of those on the test. You're going to have a lot of practice questions about cones on today's homework. And you're going to have answers also. Any question about here?
Small question.
Yep.
Thing isn't working.
What do you mean?
No, like I'm just confused. The equation is log of the volume equals 1/3 pi r squared.
Mm-hmm.
I have one question.
Yep.
So can you use like the second relationship on like another shape? Like can you use it on for the cube, or it's just only a cone?
Only in the cube. Only in the cube. A cube doesn't have a similar relationships. The only time you have similar relationship is with cone and shadow. Similar triangle is the only one. So this question used to be on AP exam a long time ago, 1990s. and this will worth 9 points on the AP exam. So this question would have worth 9 points. They no longer test this. So the reason why is people no longer able to do this kind of stuff because people gotten weaker as it goes. But I think it's very important for students to figure out a relationship and knowing what's going on. So this is, I call it classical problems. And this classical problem, I think I will visit all the time and I'll test you on it. And if you don't know how to do it, it's not end of the world because they no longer test on FRQ. They used to. They used to test the whole question on FRQ about this. And you have to understand how to do it. And it's 9 points, so that's what literally 10% your grade right there. If you don't know how to do it, then you pretty much screw. But still, it's good to practice. Now we're gonna talk about second questions, which is the which is this part. So I want you to read the second question. This one is a shadow question. It's a very interesting. This is another classical problem that a lot of students have struggled with. Okay, so let's read this question. A man is 6 feet tall, walk at a rate of 5 feet per second away from the light that's 15 feet above the ground. See his figure. I didn't have a figure. You have to draw it. When he is 10 feet from the base of the light, at what rate is the tip of his shadow moving? B is asking, when he is 10 feet from the base of the light, at what rate is the length of the shadow is changing? Now you're going to read this question again on A and B, and you're going to tell me whether they are the same or they're different. If they are the same, why they are the same. If they are different, why they are the different. Okay. You want to compare between A and B. I need Sean to be here today too.